Right. So now with dimensional model hierarchies, we want to be able to model in our data warehouses some kind of idea of a dimension that can have variable depth. And I'm not going to worry too much about denormalization or normalization when it comes to dealing what the proper hierarchy is. For the purpose of this class, I will give you a structured hierarchy. But it's important that we understand what hierarchies are. So there is a purposeful standard way that we want to group our data within a dimension. So let's say, for example, that we're given a table that is simply the city, the county, and the state. Now, in a normalized database, a lot of times you would have these as 3 different tables. So what would happen is you would have a list of cities, and then you would have a foreign key that would give you the county that would now be linked to the county table that would give you a list of counties, and that county would have a foreign key that would connect it to the state. So you would basically see 3 different tables. And this is what we call denormalization. And the reason why this is done is that it increases the amount of storage, it makes it more efficient use of the storage capacity of that particular hard drive. Well, in this same type of environment, city, county, and state, we may decide to keep all of those in one table, right? Because it will be retrieved faster. So this is the idea of denormalization. However, if we decide to normalize it and break those into different tables, now we have to create a hierarchy, right? So for example, a hierarchy of a city, county, and state is at the highest level is a state, because in a state resides multiple counties. And within a county resides multiple cities, right? So the idea is that at level 1 is the state, level 2 is the county, and level 3 is the city. And these create that hierarchy. Another example might be something that you would be a product. And of a product, you might have different subproducts, right? And then, of course, so this might be an example that your main product might be your metal products and then your wood products. And then your subproduct would be a metal-based, figurine, and the other one would be a wood-based figurine. So those would be your your subproducts, right? No, but like figurines, and then the product would be wood or metal. So that's kind of like the parent. All right. So these are some basic hierarchies, and we can explore some of those as we kind of move forward. Now, the choice of using a hierarchy in your data warehouse is simply up to you as the designer. So here's a basic hierarchy, and this is what's called this is a product hierarchy, and it starts with the product dimension, and that product might belong to a certain family, and then that family would go into a category and then into a group. And the way that this is designed, if this was at 4 different levels, the group would be the highest level, so I'll call that level number 1. The category would be at the 2nd level, family would be the 3rd, and the 4th, the lowest level, would be the product itself. So this one might actually be, let's say that a wooden figurine of Jabba the Hutt. Well, the family might be going to Star Wars, the category might be wood, and then the group might be toys. Okay, so this creates a hierarchy. And this is a typical way of how it's modeled. And in a hierarchy, you'll notice that the fact table is at the bottom, it's at the bottom here in this diagram. And the lowest level of the hierarchy, remember this is level number 4, is the one that is closest to the fact table. So if we were going to take our other example of city, let's say we had state, county, and then city. City is the lowest level. This is 3. And then if we were going to model this into our data warehouse, city would be closest to the fact table because it is the smallest or lowest level of that hierarchy. That means state would be off here, this would be county, and this would be city, and this wouldn't exist. Another thing to take note of with the hierarchies, and students tend to miss this, is looking at the relationships. Now, if you notice earlier, I always said that the fact table is going to have the one-to-many relationship. Well, as you move through the hierarchy, as you go towards the fact table, it's always going to be the one-to-many relationship. Okay. There are exceptions to this rule, but that is the general direction of hierarchies. Here's another example of a hierarchy. So you have all dates, then you have year, you have quarter, and then you have month. Okay. So what you may do is if you were modeling this, you would have month. If you put this in separate tables, you may have month in the lowest or the one closest to the fact table. And then you would have quarter as the next, year and the one following. And all would not exist, actually. All would end up becoming like, it would be like the culmination of all of them put together. Right? So you would have 3 layers to your hierarchy. You'd put the month close to the fact table, quarter would be your next table, and then year would be the one after. So, all right. Let's see if sorry about the zooming. All right. Here's another type of hierarchy. This is like a business organization, right? So this could be the executive level, or the executive level. This could be direct report or the VP level. This would be the managerial level, supervisor level, and then the product line level. Right? And these can be all put together in different hierarchies as well. Not all hierarchies are balanced. Here's what we call a ragged hierarchy. So obviously you would have city, state, and country if we were looking at the US. However, in the UK, they don't have a state or a province, and you may skip that and go straight to the UK. So this is another style of hierarchy. This would require some more advanced modeling, and we're not going to get into that in great detail with within our course. All right, so I'm going to pause here, and I'm going to pick up slowly changing dimensions in the next video. Slowly changing dimensions are very important when it comes to our dimensional models, and we'll talk about that as we move forward.